One more example of finding components of vectors where we're using a tilted axis. This one is talking about forces. We haven't worked with forces yet, but because they are vectors, meaning they have a magnitude and direction, we work with them the same way. We can talk about having x and y components. Again, when we deal with the coordinate system given, they're showing us that down this way is positive x, up this way would be negative x. Anything pointing up towards the y would be the positive y direction. Anything pointing down would be the negative y direction. So if we think about an original traditional Cartesian coordinate system, to get to this new coordinate system where x points down this way, we are rotating our coordinate system by whatever the slope angle is. So 30 degrees in this case. That means the y-axis is also rotating by 30 degrees, whatever the slope angle is. Right? We could come over here and say this was our original x. We had to go down by 30 degrees, this angle, to get the x-axis to line up with this slope. All right, so our vector itself, we need to draw in x and y coordinates. That's how we're going to find out the components. So we're drawing ourselves a right triangle where the vector, this force vector, is the hypotenuse. So our force vector is originally up and down. Our new y-axis is over here. So we know this angle is 30 because we see it right there when we think about rotating the coordinate system. That tells me the angle in here is 30 degrees. So I like to draw my components in, my y component just along that y-axis. And then remember x and y have to meet at a right angle, 90 degrees. Right here has to be 90 degrees. So my x component ends up tilted just like our x-axis. So the x component is parallel to that x-axis. To solve for this x component, we can see here that it is opposite this angle we know. And so we'll end up using sine of that angle is going to equal this x component we're calculating for divided by the hypotenuse. Here it's telling us our force vector is 10 newtons. We'll talk about newtons later. We can say the magnitude of this force is 10 newtons. So to solve for the x component, we would have 10 newtons times the sine of 30. But we definitely need to think about direction. Do we say this x component is positive, or do we say it's negative? Well, we know it's pointing this way, essentially, which, since this is labeled as x, that makes it positive. So we can say the x component of this force is 5 newtons. The y component over here is adjacent to the 30 degrees. I can say the cosine of 30 degrees is equal to this adjacent side, represents the y component of the force, divided by the hypotenuse. So the y component of the force, at least the numerical value, is 10 newtons times sine of 30. But again, is it positive or is it negative? We know it's pointing essentially this way. It's not that long. I'm just trying to represent where the arrow is. Since that's away from what is labeled as y, that makes it a negative y component because it's pointing in the negative direction. Uh-oh, I made a mistake. Do you see where it is? So as I said over here, cosine 30 is Fy over 10, but I didn't write it out correctly down here on the bottom. If I solve for Fy, I get 10 cosine 30. Those mistakes are easy to make. So negative 8.7 newtons. These would be what we consider the x and y components of this force vector based off of the coordinate system given in the problem. Now again, as far as this first section that we've covered so far, our main application of a tilted axis is finding the acceleration on the slope without friction. But after this initial motion section, we're going to start talking about forces, and we will be using this concept of a tilted axis more. Not all the time, but more. So we just need to be aware of how to find components regardless of how our x and y axes, whether they're the traditional horizontal and vertical or if they're tilted in some way.